The sun is going crazy and scientists are puzzling over what this will mean for us now. If the sun's magnetic field flips, we could have a serious problem on Earth. At the moment, we are in the middle of a solar cycle that could bring us a magnetic solar storm on the scale of the Carrington event of 1859. What are the real risks to our civilization, and when will the megastorm hit us? Inside the storm, huge convection currents create a force field. Forces of induction and deduction ensure that the masses of extremely hot solar material are constantly whirled up. This is how the magnetic field or force field of the sun is created. We are so dependent on this magnetic field that it determines which particle currents hit us and with what intensity. We know these currents as solar winds, and they shape our Earth's climate. Plasma currents from the sun are a blessing for us because they make our Earth warm, enable vegetation and life, and the sun's light illuminates our world. However, solar currents can also be our downfall. In the 19th century, a huge solar storm paralyzed the then still very young power supply for days on end. That was the last known major event of its kind. A lot has changed since then. Today, we are a civilization that depends on electricity, and we can imagine what such a solar storm could do to our planet today. Imagine how your fridges would stop working in the morning, the coffee machine would stop working, and the sky would be a sea of colorful lights. All communication media would be down, and no one would be sure what had really happened. We can imagine that some people on Earth are quite worried about this threat, so it's no wonder that researchers are monitoring the sun around the clock. And things have emerged here in recent days and weeks that don't seem quite normal. The biggest concern is the sun's magnetic field. Could it be that the field is about to flip or even undergo a massive collapse that could threaten us all? What is actually happening inside the sun? To understand the real threat, we need to go to the beginning of the sun. Imagine a point in time 4.5 billion years ago. In a cloud of gas and dust, our sun was born. Given these facts, do you ever wonder how a gigantic and blazing hot ball of fire could have been created simply from dust and gas? This question is still one of the great mysteries of science. We currently know so much that this collection of dust and gas was set in motion at some point. Due to processes that are as yet unexplored, this movement becomes faster and faster. At some point, it's so fast that the pressure inside became so strong that the atoms of hydrogen and helium fused. This generated incredible amounts of heat, and the sun began to glow like a gigantic power station. And it still does to this day. The basic principles of fusion processes at the atomic level are the same processes of induction and deduction that we still find today on the surface of the sun and in its interior. The bubbling in the deep layers of the sun creates convection and plasma currents that are pushed upwards. The solar magnetic field is created by the electrical and magnetic processes in the interior. The sun consists not only of gases such as helium and hydrogen, but also of numerous other elements and metals that enter into complex interactions. All in all, the fireball, which can be seen day in and day out in the sky as a yellow disk, is a highly complex marvel of chemical and physical processes that are so perfectly coordinated that we can only marvel at them. For once, the perfection of the universe can leave us in awe. But how does it fit into the picture that our life-giving fireball can also become such a threat to us? The greatest danger comes from sudden and unpredictable events on the surface of the sun. The magnetic field is very dynamic and changes from time to time. Due to the immense turbulence and dynamics, the solar magnetic field is different from that of the Earth. The magnetic currents are constantly changing, and we humans observe these changes meticulously because they have to do with the sun's plasma ejections, which can bombard our Earth with streams of particles. Normally, even the most violent solar storms would hardly harm our Earth. It knows how to protect itself, and the particle bombardments do not harm the planet itself, animals, or our bodies. Only our electricity systems, satellites, and communication systems are susceptible to disruption. As we are totally dependent on these systems in the 21st century, and in some cases even our lives depend on them, we are at risk. Airplanes in the air could lose their bearings and have to land in dark airport facilities at night if the power and navigation systems suddenly fail. Hospitals would be in distress. ATMs and cold chains in supermarkets could fail, and ultimately, the biggest risk is mass panic that could break out among people if the sky is on fire and the familiar environment no longer functions. Does it really help if we understand solar cycles? Did you know that we are currently in a solar cycle that could bring us an event similar to the solar storm of 1859? The Carrington event went down in world history. Telegraph stations failed all over the USA and the world. This technology was the ultimate at the time and comparable to today's telephones and smartphones. For the first time, people around the globe were able to communicate and coordinate. Of course, these communication networks were still slow compared to today's standards, so it took quite a long time before it became known what had really happened back then. A huge solar eruption had hurled plasma towards Earth, and this plasma was caught by our Earth's magnetic field. The Earth's magnetic field normally protects us from excessive radiation from the sun by collecting particles, binding them, and allowing their charge to run dead. If the particle density is as high as in 1859, the protection does not work properly, and more particles penetrate into the deep areas of the Earth's atmosphere. This happens more frequently at the poles, and we all know and love the effect in the form of the magnificent auroras and polar lights. In 1859, this is exactly what happened. The magnetic field was not sufficient to protect us and allowed large amounts of charged particles into the deep layers of the Earth's atmosphere. People all over the globe saw the auroras in regions where they do not normally appear. Sparks flew from the sparse electrical systems of the time and caused fires. Other electrical systems functioned solely through the electricity in the air and telegraphed nonsense around the world as if by magic. At times, people thought it was God's revenge or the Last Judgment. Only the researcher Richard Carrington had recognized what had really happened. Carrington had studied the surface of the sun and observed a striking change, which he later became the first scientist on the globe to correctly interpret as a solar flare. A few days passed before the news made the rounds. Then relief set in, and after 2 weeks, the whole spook was over. Today, a similar event would knock out all our communications and probably the power grids regionally. From Carrington's insight, the science of studying solar activity and solar cycles developed. We are currently in an 11-year cycle that will reach its peak in 2025. But something is wrong with the sun. It is behaving strangely, and here comes the fatal part. Scientists feel safe because they thought they knew the sun and its activities quite well and could make reliable predictions. But the sun shows our researchers that it is not as predictable as they had long assumed. If we take a closer look, we quickly see that in-depth research into solar activity has only been providing us with reliable results for a few years. The rest of the predictions are based on computer simulations and old observation data obtained with fairly simple telescopes. Scientists use this data to create a solar calendar and their predictions. However, we are currently seeing that these do not always have to be correct, and there may be much worse to come. Worrying change in the sun's magnetic field. In the spring of 2024, an unusual spot appeared on the sun that brought us such violent solar storms in the first half of the year that researchers are baffled. The auroras generated by the storms were visible in the USA, Southern Europe, and even in Hawaii and Australia. Although the power outages were only regional, even Elon Musk was shaking for his brand new Starlink satellites at times. If this was just the beginning, what will the peak of this solar period bring us? Or was this already the peak and our scientists were wrong again when they predicted the most violent storms for the year 2025? In recent years, the sun has been so unpredictable that we have to expect big surprises. In practice, we have to realize that a storm that paralyzes everything can theoretically hit us at any time. If we remain realistic, we have to face the unpleasant truth that the sun has often shown activity that does not fit into previously known cycles. In 2003, the flare that led to the violent Halloween storms was detected just a few minutes before it arrived. Particle streams from the sun sometimes only take 20 minutes to reach us. Larger ejections and clouds can sometimes travel for 2 days before they hit our magnetic field. If the sun now shows a devastating jump in its magnetic force, it could become even more unpredictable. Such a gigantic solar storm could race towards us, possibly causing far more damage than the Carrington event. Researchers here reassure us that the jumps in the sun's magnetic field are actually quite normal. They argue that the changes in the sun's magnetic field could very well lead to even more violent upheavals and eruptions, but they still don't see an all-destroying monster storm coming. They are still certain that major solar eruptions will be announced by sunspots or detected in good time by our solar observatories. Time will tell whether this certainty is genuine or whether we will one day be in for a surprise. Become a subscriber now and be part of every new video.